This is our notes for 8.4, which is all about finding the sum of an infinite geometric series. This will be the last section that we cover in Chapter 8 this year. So after this, we're just looking forward to getting ready for reviewing for our assessment this chapter. So we'll go ahead and just dive right in, because today's not too bad. It's just really one formula, kind of two, I guess, new ones. One new one, one recycled one. Looking here in box 1, when we're dealing with an infinite geometric series, that means, obviously, an infinite series means my terms don't end. It continues on into infinity. As we talked about in 8.3 last week, we can't find the sum of an infinite sequence or an infinite series. It has to be finite, meaning there has to be an end to it. Otherwise, if it just continues moving on into infinity, it can't, it just keeps getting bigger and bigger, so we can't find the sum of it. What we can do, however, if it's an infinite geometric series, we can find something that's just called a partial sum, which is basically just looking at a part. Obviously, it's a partial sum. It's a sum of the first part of the series. So in this one, it's the exact same formula we looked at in 8.3. This formula tells us that this was the formula we used for a sum of a finite geometric series, because that's really all a partial sum is. We're just taking that infinite series and cutting it off at a certain point and finding the sum of the first n terms. So here, all the same things. A sub 1 is still my first term of my sequence. R in both of these places is still my common ratio or my multiplier. And then n is the number of terms. So if we're finding the partial sum of the first 20 terms of the series, the 20 would be my n, my r would be the multiplier of the series, and then a sub 1 is that first number in my series. So we can go ahead and apply that here to box 2. In box 2, we're finding s sub 5, meaning we're finding the sum of the first 5 terms of this series. Now, it's already written out, the first 4 terms, so I guess if you really wanted to, you could just use a calculator. I mean, you have to figure out what that 5th term is, but you could also just use a calculator to find the sum of those first 5 terms. But usually where we'd use this formula would be something much larger, like we're finding the first 75 terms of the series. And in that case, we're going to want to use our formula. So again, for our formula, we need 3 different things, and I'll make a little checklist over here. We need our first term, a sub 1, we need our r value, and then we need n. Now, a sub 1 and n, we already know. A sub 1 is a half, that was my first term, and n, they want us to find the sum of the first 5 terms of that series. So all we really need to figure out is what r is. And remember, r is what I'm multiplying by to get me from 1 to the next. So if I go from a half to a fourth, I have to multiply by a half, because my top doesn't change, 1 up top. 2 times 2 is 4, so a half times a half is a fourth. And then a fourth times a half is an eighth times a half is a 16th, so on and so forth. So we've identified what my r value is. That is also 1/2. So from here, what we have to do, we're going to go ahead and I'm just going to rewrite my formula, substituting those different values in here. So I remember my formula, s sub n, the sum of the first 5 terms, is a sub 1 times 1 minus my r to the n all over 1 minus r. So I'll just substitute everything in there. Now I just need to use my order of operations skills to simplify that. So 1/2 up top or outside. This 1/2 to the 5th power is 1 over 32. 1 minus 1/2 is a half. So if I simplify, I'm just going to go to the right here. 1 minus 1/32 is 31 over 32. Not 31 over 22, 31 over 32. All over a half. Now you could do some fancy stuff with flipping and multiplying by a reciprocal to get that 31 seconds over 1/2. But we can see here, we also can just be fancy this way, and that 1/2 on the outside and the 1/2 in my denominator are going to cancel out, and my sum of the first 5 terms of the series is just 31 over 32. All right, continuing with box number 3, now we are going to find the sum of an actual infinite geometric series with the first term a sub 1 and common ratio r, which is our common multiplier. So we have this formula that worked for finding the sum of an infinite geometric series, which just basically simplifies our formula down to just a sub 1 over r, 1 minus r. So now the only thing we need to know, since our sum is infinite, we don't need to know how many terms it is. We don't have an n value because it's just infinity. So all we really need is my first term and my multiplier, right? Which is what those two things are. The issue is, or the stipulation here, is that this only works if your multiplier, your r value, is less than 1. And really here, this is absolute value less than 1, meaning something between -1 and 1. So an actual, like a fraction. Doesn't matter if it's positive or negative, some decimal or fraction between 0 and 1. Again, either positive or negative. The reason that this works is because, or I guess the reason that those ones work is because if we look at a series, if my numbers keep getting bigger, there's no way I could ever find the sum, which is what this bottom sentence is saying. If my r value is bigger than 1, the numbers keep getting bigger every single time, and there's no way I can find the sum because each term is going to be bigger than the next. But if my multiplier, my r value, is less than 1, right, it's between -1 and +1, each number in my series, as I go further along in my series, gets smaller and smaller and smaller. So what some really, really smart dead dude eventually figured out way back in the day is that those numbers converge on a particular value. And they were super smart and realized that this formula gives us that value that they converge to, and then, their sums. So that's why those work. It only works if your r value is between 0 and 1. So something like 1/2 or 0.3, those would work. We will find our sums. If we have anything where their r value is either bigger than 1 or smaller than -1, it's not possible to find the sum, and we would just say no sum. So let's go ahead and jump in here for box 4, for actually finding some sums of infinite geometric series. So again, with these, before we plug anything into our formula, the first thing we have to check on is if this fits my requirements. Is my r value between 0 and 1? Well, the absolute value of it is less than 1. In this case, my a sub 1 is 3. My r is 0.7, so that does fit. Right? My r value is 0.7, which is between 0 and 1. So then I can go ahead and just use my formula. My sum is equal to 3 over 1 minus 0.7, which is 3 over 0.3, which is just 10. So the sum of the entire series, the entire infinite series that starts at 3 and is 70% of its previous value, converges just on 10. Pretty cool. Number two, we've got to see, now this one is not given to us 2 and 3. We're both going to have to find what r is before we can actually evaluate what it is. So we see a sub 1 is just 1, which is fine. But going from one to the next here to try and figure out what my r value is of this series, we can see that we're multiplying by 3 each step of the way. And since my r value is 3, that's bigger than 1, right? You can see my series, my numbers keep getting bigger and bigger. That means that this value, or this series, has no sum. Right? We can't find a sum because my numbers keep getting bigger instead of continuing to get smaller. So they don't converge on a value, they just keep going on into infinity. All right, last one. Number 3 in box 4. So same thing, R value, or sorry, my A sub 1 is just 1. My R value I have to try and figure out. Now, this is another one where my sign alternates, which means I'm multiplying by a negative number, right? Because if positive 1 times a negative gives me a negative times a negative will give me a positive. And the nice thing is here, I'm starting at positive 1. If I'm taking 1 times something to give me negative 3/4, super easy. Negative 3/4 has to be that thing. Which also, if you look at, does it fit moving forward? It does, right? Negative 3 times negative 3 is a positive 9. 4 times 4 is 16. If I multiply it again by a negative 3 over 4, 9 times negative 3 is negative 27. 16 times 4 is 64. So it does fit with my series. So that tells me R is negative 3 over 4. And we already figured it out that A sub 1 was just 1. In this one, even though it is negative, doesn't matter to us as long as it's either less than 1 or bigger than negative 1, which in this case it is. This would be 3/4, which is 0.75. That is definitely an R value that works in my series. So to go ahead to my formula, my series sum is just A sub 1 over 1 minus R. So here I have to, my negative, right? Subtracting a negative is like adding the opposite, or adding the opposite, adding a positive. So this is 1 over 4/4 plus 3/4, which is 1 over 7/4. So when I try to simplify that, I'm going to just go ahead and flip to multiply. Right, this just becomes 4 over 7. My sum is 4 over 7. Because 1 divided by 7/4 to multiply by a fraction, right? I multiply by the reciprocal. So my sum is just 7/4. That is all we got for 8.4, which is actually the last thing for Chapter 8 that we'll do before our assessment. Your homework for tonight is on page 439. You guys have just 6 through 16 all. So both evens and odds, 6 through 16 all. You guys, as always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.